Well, we're going to finish our discussion, or at least continue, on the chain rule. And just to kind of backtrack a little bit, what we talked about, how finding the derivative of a problem like in part A, not a big deal because you can just expand it, multiply it out, and then take the derivative. A little bit bigger deal if it's cubed. I didn't want to do that. I didn't want to multiply it all out. A problem here, we actually, 2x plus 5 times itself 6 times would be rather time consuming, and this we just couldn't do that way. So we're going to use something called the chain rule, and you can read over this later. I kind of paraphrased it here. So in order to use the chain rule, what you're going to do is take the derivative of the outside function with the inside left unchanged. And in this case, using the power rule, 2x plus 5 would be the inside function, and then something squared is the outside function. And then you're going to multiply that by the derivative of the inside function. So looking at some examples, this one, the derivative of the outside function using the power rule would be 2, and then that something left unchanged. And then we could put a 1 here, but I didn't need it, times the derivative of what's inside. And then I multiplied the 2 times 2 and cleaned that up a bit. Then on this one, and I did not do it without the chain rule, the derivative, the inside function, again, is 2x plus 5. So the derivative of the outside function would be 3, and then you'd have 2x plus 5, that quantity to the second power, times the derivative of the inside function, which would, again, be 2. And then I just multiplied the 3 times 2. Then on this one, where this comes in very handy, so the derivative of the outside function with the inside left unchanged would be 10, 2x plus 5, drop the power down to the 9th power, times the derivative of the inside function. This one we changed to a negative 2 for the exponent, use the power rule, so the outside function, negative 2, 2x minus 5 to the negative 3, times the derivative of the inside function, which would be a 2. And then on this one, to the 1/2 power, so we would have 1/2 times this to the negative 1/2 times the derivative of what's inside. Then for number 5, and I didn't use the quotient rule, I just went ahead to show how you would do this with the chain rule. So you're going to do the derivative of the outside function again, so negative 1, or just negative, 4x minus 3, drop the power, times the derivative of what's inside, and then clean it up. And on this one, I rewrote this to avoid the quotient rule. I rewrote this as to the negative 3rd power. And when you have a number out front, when you bring this power down, you just multiply it. So we have negative 9, then this something here, to the minus 4. So that's the derivative of the outside function with the inside left unchanged, times the derivative of the inside function, which was 6x minus 2. And then you could just kind of clean it up. We could have done more, but didn't. So here's the new stuff. So keeping on with that, notice the inside function is 7 minus 4x squared. The outside function is that something to the 2/3 power. So when we get f prime of x, we're going to have 2/3 times 7 minus 4x squared to the negative 1/3 times the derivative of the inside function, which of course this part's 0, so we get negative 8x. So then I can just bring this over here. So we're going to end up with negative 16x over 3. And I'm just going to leave this with a negative power like that. Okay, so for the next one, I'm going to write f of x equals negative 5, and I'm going to change this to x squared minus 4x plus 1 to the 1/2 power. So now I have it set up. So the derivative, it's going to be 1/2 times negative 5, so negative 5/2 times x squared minus 4x plus 1 to the negative 1/2. That's the outside. That's just the derivative of the outside function with the inside left unchanged, times the derivative of the inside function, which is 2x minus 4. So then we get, notice that I can cancel this 2 with this, and I'm going to just do it like this. So I'm going to cancel the 2, and that's going to make this an x minus 2. So now we have negative 5 times x minus 2, and I'm going to go ahead and make this the square root of x squared minus 4x plus 1. Okay? And the last one here, not the last one though. Let's write this as negative 2 times 6x minus 1 to the negative 1/4. So then f prime of x, we're going to multiply, so the derivative of the outside, so we're going to have a fourth times 2 is going to give us a half, so we have 1/2 6x minus 1 to the negative 5/4 when we subtract 1. So again, that's the derivative of the outside function with the inside left unchanged, times 6. This is going to do a little canceling. So we get f prime of x equals 3 over 6x minus 1 to the positive 5/4. All right, so the next part on here talks about the different forms we have for differentiation. We use the power rule, so you see that a lot. There are many times we use the product rule where you have two different functions being multiplied together, and we have to use the product rule. And lots of times where we have to use the quotient rule. Now, the chain rule is not quite like that because the chain rule is always going to be in operation. And they actually give you an example that we don't even think about. If you take the derivative of 7x squared and you get 14x with the power rule, remember the derivative of x is 1. So it's when you do that, it's like the derivative of the outside function with the inside left unchanged, and then the derivative of the inside function would be 1. So technically, the chain rule is in effect here too. It's just we don't really need it there. So we will come back to the chain rule, and I've said this before, it's actually just, we're always going to be using it. So you absolutely have to remember the chain rule, but then we're going to apply it in these different situations. So for this first one, in this case right here, I'm going to have to use, I'm going to have to use the product rule. Because notice that I have an x squared times a 2x minus 3 to the 4th power. But because of this 2x minus 3 to the 4th power, I'm also going to need to use the chain rule. So I'm thinking of u as x squared and v as this right here. So then we're going to have u prime is 2x, and v prime, this is where I'm going to use the chain rule, we're going to have 4 times 2x minus 3 to the 3rd power, then times the derivative of what's inside, which would be 2. So I get 8 times 2x minus 3 quantity to the 3rd power. So I do all that, and now that means the derivative, remember it is u prime v plus uv prime. So we're going to have u prime times v plus u v prime. Okay, and then I'm going to see how we can clean this up. So we have a 2x minus 3 to the 4th power plus 8x squared times 2x minus 3 cubed. So I can do some factoring here. Remember, this is two terms. I have a term here, and I have a term here. This is a little algebra lesson now. And I want to factor out my common factors. So clearly I have a 2, and I also have an x. But I also have a 2x minus 3 to the 3rd power, because I can take 3 of these factors out of here and all 3 of these out of here. So this is what I'm going to factor out. What do I have left? Well, I have a 2x minus 3 from here, and I have a 4x from here. Hold on. I just changed it to a bracket there. So anyway, I factored out a 2x and a 2x minus 3 cubed. That left me a 2x minus 3, just one of the factors left of that, plus a 4x. So then I can still clean this up a little bit more. So we have 2x minus 3 to the third power, and here I can combine like terms and I get 6x minus 3. And actually, while I'm factoring, I could actually take another 3 out of this. So I'm going to take a 3 out of this 6x minus 3 and put it up here in front. So we actually would get 6x, 2x minus 3 quantity cubed, and then after I've taken the 3 out, I have a 2x minus 1. So you might wonder, well, why is this a bigger deal? Notice that this is all in factored form. There is going to come a time very soon where we are going to set the derivative equal to 0. To do a lot of stuff in calculus, we want to set the derivative equal to 0. Well, when I want that makes it's easy here. If I set the derivative equal to 0, I could solve for x super easy because I could right here, x equals 0, x equals 3 halves, x equals 1 half, and we can solve that easily. Not so much if it's in this format. So notice that the calculus is done at this point that I kind of have underlined in red. I finished doing calculus. Now it's algebra. So sometimes that's the part that gets students, is not being really confident with the algebra. So we really need to make sure that we are practicing those algebra skills. All right, so the next one, we have also the product rule. But first I'm going to rewrite this as x times 4 minus x squared to the 1/2 power. So this is u and this is v. Actually, I have another way that I do this too. I'll stick with this though. So u prime is 1 and v prime is 1/2 4 minus x squared to the negative 1/2 times the derivative of what's inside, which is going to be a negative 2x. So my 2's cancel. And we have x. I'm going to leave it this way. I might regret, oh, it's negative because of the negative sign. All right, so I have that. So then f prime of x, we're doing u prime v, so that's 1 times v, so we get this, plus uv prime, which is just going to be x times negative x, and then this, all over v squared. No. Redo. Okay, that would be the quotient rule. And that's not what we're doing. And it would have been the quotient rule wrong because I added. But anyway, so let's see what we need to do to simplify this. So I'm going to change this back to radical form. I've got the square root of 4 minus x squared plus, let's make that a minus since this is a minus sign in here, minus x squared over the square root of 4 minus x squared. All right, so we need to simplify this, and I'm going to need to find a common denominator, and I'm going to find that by multiplying the numerator and denominator by this 4 minus x squared. So when I do that, multiplying in the top, notice it's the same thing. So I'm squaring the square root. So I get 4 minus x squared. And then I'm going to have minus x squared over my common denominator. Okay, so all I've done is find a common denominator. Then that gives me 4 minus 2x squared over the square root of 4 minus x squared. And you're fine leaving it like that. If you wanted to, you could factor out a 2 out of the numerator, but we wouldn't be doing anything with it, so we can just leave that. Okay, next one. So on this problem, we're going to, now notice that this, and I hadn't really talked about this, this was product rule. I was going to identify the form. This one here is power rule. That's kind of the format. So I'm going to use, so to find f prime of x, I'm going to do the derivative of the outside function with the inside left unchanged. So that's going to be 5 times 2x minus 1 over 2x plus 1 to the 4th power times the derivative of what's inside. Well, that's going to require the quotient rule. So to get the derivative of what's inside, and I'm going to do this down below here to show the work. So u is 2x minus 1. V is 2x plus 1. So u prime is 2 and v prime is 2. So to get the derivative of that, I need u prime v, so that's going to be 2 times 2x plus 1 minus uv prime. So I'm going to put the v prime part first since it's a 2 times u all over v squared. So that's going to be 2x plus 1 quantity squared. All right, I'm actually going to erase this so it's out of my way. All right, so what do we have? We're going to, we can actually, because now we want to just work on simplifying this. So we've got, I'm going to actually distribute here. So I'm going to leave this alone. And distribute in both of those spots. So I get 4x plus 2 minus 4x, and then that's going to distribute here too, plus 2 over this. So the 4x's cancel, and I'm left with 5 times 2x minus 1 to the 4th power, and this is going to be a 4 over this. So I can actually multiply the 5 times 4 and get 20. Also, and I'm going to separate this out for you guys. Because I just want to show you, because I can do that. And then notice my denominator. So I'm going to just multiply now, multiplying these fractions. So I'm going to get 20, 2x minus 1 to the 4th power. And then in the denominator, I'll have 2x plus 1. Add the exponents, so we get the 6th power. So this is my answer. Okay. Number 13, basic form is the quotient form. So here's u and here's v, and I'm going to think of v as x squared minus 1 to the 1/2. So then v prime is 1/2 x squared minus 1 to the negative 1/2 times the derivative of what's inside, because I have to use the chain rule. The 2's cancel and leaves me with x. I think I'll leave this in this format for now. Okay, so that's my v prime, and u prime is just 1. So f prime of x, u prime v, so it's going to be 1 times x squared minus 1 to the 1/2 power. So we have u prime v minus u v prime all over v squared. Well, that's interesting. If I square that, I just get x squared minus 1. Okay, so cleaning this up a little bit. So we're going to have I'm going to change this to the square root of x squared minus 1. And here we're going to have minus, and I'm going to write this as x squared over the square root of x squared minus 1. And then this whole thing is over x squared minus 1. So I would do that. And then we could do a similar thing that we did before. So I'm going to multiply this to get a common denominator. The square root of x squared minus 1 over the square root of x squared minus 1. So now and again, that multiplies out. It's going to cancel out. So we get x squared minus 1 minus x squared over this. And that's all over x squared minus 1. Remember, if you're dividing by that, I'm going to write it like this. I don't know if this is going to do us any good or not. So the x squareds cancel, and I get negative 1 over okay, I think I'm going to leave it like that. There might be a simpler way, not leaving a radical in the denominator, but this will work. Actually, I just thought of something. Because this would be, this is like having negative 1 to the 1/2 power here. And then you add the exponents. Bases are the same, you're multiplying, so you add the exponents. So that would make this x squared minus 1. 1/2 plus 1 would be 3/2. So if we were going for simplest, this looks good. But you know, if you get at some point of that, you don't always have to have the simplest answer or in simplest form. Because I know the algebra can get really complicated on some of these. Okay, so on this one, the main, we're going to rewrite f of x. This is going to be a power rule problem. Of course, we're going to use the quotient rule as well in the process. So we're going to take x over 4x minus 1 to the 1/2 power. So then f prime of x is going to be 1/2 x over 4x minus 1 to the negative 1/2 power. And then we have to take the derivative of what's inside. So, because we're going to multiply by the derivative of what's inside. So this is the whole u prime v. So u is x, so u prime is 1. V is 4x minus 1, so v prime is 4. So u prime v is going to be 1 times 4x minus 1 minus uv prime, so that's going to be x times 4, or 4x, all over v squared, so 4x minus 1 quantity squared. So the 4x's are going to cancel, and we're left with, well, let me write it out. I think we have a negative 1 there. Okay, I'm pretty sure I know there's a little more we can do, but we're going to call it good on that one. Okay, for the next one, I'm going to use the product rule. Okay, so this is u, this is v. So then u prime is going to be, and we're going to use the chain rule on that, it's going to be negative 3. I probably need more room. So we're going to have negative 3, the inside left unchanged, to the negative 4th, times the derivative of what's inside, which is 2x. So then I have negative 6x times x squared minus 4 to the negative fourth power. So that's u prime. V prime, using the power rule, so we've got all these different rules going on here, but we have 3 times x squared plus 4 to the second power times the derivative of what's inside, which is 2x. So I get 6x times x squared plus 4 squared. So remember, we need u prime v plus u v prime. So f prime of x, u prime v is going to give me this negative, write small, 6x, x squared minus 4 to the negative fourth power. That's u prime. V is x squared plus 4 to the third power, plus uv prime is going to be x squared minus 4 to the negative 3 power, and then v prime was 6x, x squared plus 4 squared. I'm going to look for any common factors that I can factor out. So let's see. All right, so I'm going to change this to negative 6x, x squared plus 4 to the third power, and I'm going to drop this to the denominator with a positive exponent, and then do the same thing here. So I'm going to have 6x, x squared plus 4, quantity squared, and this would be x squared minus 4 cubed. And I actually could find a common denominator by multiplying by another factor of x squared minus 4. I could factor out a 6x. I could combine this and get this to a single expression, but we're not going to. Okay, so we're going to just stop it at that point. I'm actually going to come back to these a different day because that has been plenty, and I would rather you practice some of the problems that we've just done, and then we'll come to, these are kind of like my favorite, I love these, but we'll come back to these the next time we have class.